Hello guys, good morning.
Morning, sir.
Okay, good morning everyone. So any doubts so far? Have you tried these things which we have discussed in yesterday's session?
Yes, sir.
Guys, I want everyone reply. So any difficulties or it's okay, it's clear as of now. Why? Because
Clear, sir.
what about the rest?
Clear, sir.
Yes, sir.
See, if you are facing any difficulties in the basic things, then it will be difficult. That's why I'm asking you. If you are having any doubt, then ask me. Otherwise, I will continue with yesterday. I mean, I will just give you a brief on yesterday's session, and we will continue the today's session.
एक्सक्यूज मी सर
Yes.
सर एक्चुअली ये इतना रिमेम्बर नहीं रहता कि जैसे क्लास लाइब्रेरी किस लिए यूज की जाती है और जैसे अलग अलग आइकन्स है ना वो थोड़े याद नहीं रहते मतलब
नो प्रॉब्लम सी जब हमने कल जो सेशन हुआ व्हाट एग्जैक्टली हैपेंड इन यस्टरडे सेशन इज द ब्रीफिंग so what exactly the plant simulation is capable of when we will be entering into in depth so I will be explaining you what exactly the role of class library how can we supposed to do with class library and how to use this class library in detail all those things I will explain you when the topic comes okay don't worry about the class library I will explain you that when we are doing the I mean larger models. Fine. Okay, let's start the
ओके
session.
सर
So which one we need to pick here? 2D or 3D?
2D, sir.
Okay, so I'm clicking 2D. This is called class library and this is our toolbox. Now what is this called as? What are we supposed to call this as?
Module frame. Module frame.
Frame, simple frame. Okay, now I'm increasing it. Uh, so for starting a model, what I need to have?
Input.
So input is,
Source.
Input.
yes, input is nothing but our source. At the same time, output is nothing
Drain.
but drain here. Now I want to use some missions is nothing but stations here. See, simple thing, I am using some 3 or 4 missions. Now if at all I want to align them, how can I supposed to align them? I want to
Sir,
align them in
first
a
it's
straight line.
right is left main box.
Sorry.
So you
Sir,
select them
first
all
left
and then you
click.
right click and align horizontally.
Okay, select everything like this or you can hold control and select each and every icon or you need to drag a rectangular box on top of all these things and everything will be selected, then right click on an icon and you will be having this arrange icons. In that, if you select align horizontally, it will be aligned horizontally. If you want to distribute it in horizontally, then distribute horizontally, so it will be distributed. Now shall I run the simulation?
No, sir, you need to connect all of the icons together.
What is the need of connectors? Why am I supposed to use this connector? In plant simulation, connector is nothing but a process. We are defining a process between these two. Then only the material handling will going to happen. Now there is a relationship between these two. Similarly, like this. Now, are they connected?
Yes, sir.
Now, now can I run the simulation or do I need to add anything?
Yes, sir. We can run the simulation.
Okay, now running the simulation. What are the different methods for doing a simulation? I
On
want
the basis time interval and or on the basis of material number of material used.
okay, number of inputs used. See here I am going to, for this one, I want to run the simulation in a time basis with respect to time. Then what I need to do here? So I have opened this event controller and event controller was opened. Now what I need to do after opening this?
Sir, first we have to
Sir, reset and slower.
Okay, I have done the reset. Then we need to
Slow
reduce the
the
speed.
speed.
Yes, we need to reduce the speed. Then after that we need to enable this one. We need to always enable this real time. Okay, now can I run the simulation? What will happen if I run the simulation? See, I'm increasing the speed. When it will going to stop?
sir, it won't stop, sir.
Why?
Sir, because we haven't defined the ending time.
Okay, how can we supposed to do that?
Sir, first we have to click on settings, then we can define that time on setting.
Okay, here time. So what is the
Yes,
notation here? What is the notation we need to follow?
sir.
Sir,
If
in seconds it accept the numbers. After in minutes we use to there are 2 points,
Okay,
and for hours other 2 points, and for days other 2 points,
okay.
like that.
It will follow the nomenclature like days, hours, minutes, and seconds. Based upon that, we need to give the input. If at all I want to run the simulation for 2 days, then two I need to give three semicolons. Then it is 2 days. If at all I want to run for 2 hours, then I need to press two semicolons. If at all I want to run it for 2 minutes, then two, one semicolon. If at all I want to run the simulation for 2 seconds, then it's only two. Okay, like I need to plan. Now I want to run the simulation for 2 hours. Apply. 2 hours I have given. Now I am reducing the speed and run the simulation. I'm increasing the speed to check how many parts. Okay, 2 hours was done. Now, how many parts was processed with this one? To check that what is the thing I need to do. How many parts have processed? To check that one, what I need to do.
So we have to check the statistics of the output.
Yes. How to check that one?
Right click and then it will go on statistics.
No right click. Actually, double click is enough. Double click
Yes,
on
yes,
the
sir.
icon. After that, we need to enter into statistics tab. In that, it was written entry 716, exit 716, which means throughput of this drain is 716. Now, what will be the input? The output is 716. Now, what will be the input? What is the throughput of input? How many parts have exited from the input? How many parts have exited from the source?
So it will be greater than 716, sir. Some part are still in process.
Okay, so what will be the figure? This is 716. So 717th part here, 718th part, 719th part, 720th part. So which means 720 parts have exited from the source. To check that one, double click on the source and statistics. See, exit 720. Okay, clear? This is the first method. Now I don't want to run this method with respect to time. I want to run the simulation for 1000 number of pieces. For that, how what is the method? I want to run this model for 1000 pieces.
We will assign the numbers on source.
Okay.
Means we will double click that and then
Okay, we have to define the source. In that source, where we need to
the,
define
the type of
creation,
yes, sir,
time
at
of
that one.
creation. In that, there is a drop down menu. Which option I need to choose? Interval or
Number
number?
adjustable.
So, number
Adjust.
adjustable. In that number, I need to give the desired input. So, if I click apply, okay, then I need to reset the simulation and run. I'm making it fast. See how much time it will take to produce 1000 parts? 2 hours 47 minutes.
47 minutes and 10 seconds.
To check that one, so drain statistics in that 1000 parts are manufactured. Okay, this is the basic principle. Now, this is how exactly we are going to run the simulation. So anything now, beneath this one, I mean, beyond this you can add anything. So this is what exactly a plant will be. Now you want to add a robot, you can add robot. If you want to add a conveyor, you can add. You want to add assembly station, you can add. So this is how the basic model will starts with. Once this is the a process was started, okay, just a second. This is how our model will going to start. This is the basic mission, this is the basic, I mean, model we have created. Now what exactly this arrow represents? What exactly this arrow or connector represents?
Material
So
flow.
movement of material.
Okay, material flow, material handling, movement of material, all these things are correct.
Direction of flow.
Okay, direction of flow, that is also correct. Now, is it okay if I use this connector in a real industry? Is it possible?
No,
Connector,
sir.
connector is nothing but it's an assumption,
No, sir.
which means a part which is processed from the station will automatically enter into this mission. This is an assumption, and with that assumption, we have created a relationship, brand relationship by using a connector. But in actual, in industry, these connectors won't be enabled. So if at all you want to create an actual model, then just a second. We have prepared this model. Now I don't want this model, so close. I am not saving it. None. So I have prepared a model yesterday, so I'm going to open that one. For that, open model file. In that model file, this one is our model. So this is what exactly we have prepared yesterday, right? So I'm running the simulation. So with respect to 1 hour, I'm going to run it. So let me check. Okay, 1 hour, how many parts it was produced? 13 parts. Fine. This is the model which we have prepared yesterday. So what happened here? What is this one? What is processing time?
So the
Sir, how
time every
much
machine
is
takes
taken?
to complete the process.
Sorry.
The
The
time
It is
by
the time taken by
machine.
machine to complete its process.
Okay. In simple thing, we'll say processing time is nothing but operating time. Okay. If a machine is there, it want to do some operation. So in general, we'll call as a operating time. But in technicality, we'll call as a processing time, which means a machine to process the work is nothing but a processing time. See here we have default is 10 seconds. In generally what happened, there won't be any machine that works with in 10 seconds. So here we are giving the actual characteristics. The actual characteristics may be 2 hours or so 2 minutes. I have given like this. And for this mission we have defined 4 minutes. And for the third mission I have defined 1 minute. And the fourth mission I have defined for 2 minutes. Now if I run the simulation, which means this one. Okay, done. Now, how to check the mission characteristics? I mean, whether the process is having any blockage or waiting. How to check that one?
Using chart.
Yes, that is why we have done this one. Now, I am opening this chart and show there is this representation. If I run it, why there is yellow face in first mission?
Because of blockage,
Yes, why it was blocked?
because speed of M2 was less than speed of M1.
Speed? No.
Production time.
Operating time.
Yes,
Operate.
operating time is the correct one. Not speed, not anything. Operating time for the second mission is more. That is why this mission was first mission is interlinked with second mission. That is why there will be having a blockage phase. Now, why the third and fourth will be having waiting phases?
Because M2 is taking more time to operate, so means M3 and M4 will have to wait so that the inputs would come to the M3 and M4 so that they can operate.
Okay. See, our complete process is depend on this processing time only. So we have to define the actual processing time. In actually a mission is doing some 5 minutes of processing time. Then we have to define 5 minutes of processing time and we have to run the simulation. That is what exactly we need to do in this plant simulation. Okay. Initially, Based upon the layout, if the layout is having 4 missions in the process or in the production line, then we need to define like this 4 different missions and input output with default values. And we need to give, if at all I want to run the simulation for 1 hour, then I need to give the time and check. So if it is a having 10 seconds of time, how many parts I am producing, that is the first thing. After that, I need to give the actual characteristics, that is nothing but these things. Processing time, how much processing time that one first mission is having, how much operating time that second mission is having. Now I need to give the inputs. Now after giving the inputs, this is the statistics I have received. This is what the statistics I have achieved. Now I am resetting it and running the simulation. With this chart, I'm going to optimize it. Optimize is nothing but increasing the production. By using these facilities, I'm going to increase the production. That is what exactly the optimization means. Now by considering this one, now what I need to do, I need to do some alter, like yesterday you said I need to add some more mission, I need to add something like this to reduce this blockage. Now see, let I'm decreasing this one. Here, what is this one? Connector. If I delete this connector, what will happen? If I delete this conveyor, will the process run?
No, sir.
Why it is not running?
Because process stopped at M1, sir.
Okay, so there is no any relationship between M1 and M2. That is why the process was stopped. Now, in generally, what we are using connectors for creating a relationship between these two. But in actually, what will happen in, if any, you will consider this as an industry, and first mission is there, second mission is there. The material from the first mission need to enter into second mission. For this purpose, I need to use some material handling devices like conveyors or a human material handling, like different things. Then only the material from this station need to be entered here. Here in this application, I am using a conveyor. See here, this is what exactly we'll call as a conveyor. We have done with connector, we have done with input output, we are done with station. Okay, these are all advanced modelings. I will tell you once we will complete the basic things. Okay, so we will be starting the conveyor here. There is a icon here that is called as a conveyor. So for enabling this conveyor, you need to click on the conveyor and a pop-up will be raised here. So here, what is this conveyor will be needed? Conveyor will definitely need two things, two inputs. One is from where exactly it need to start and where exactly it need to end. Then the conveyor will be prepared. So this is what exactly a conveyor is. Now I don't want here, so I am deleting it. So clicking a conveyor. Now where exactly I want to start it? I need to start at
M1.
M1. I am clicking this
M1.
one. Next, where it need to end?
M2.
So I am dragging it to M2, and at M2 I am going to click another one. Fine. There is a conveyor that is enabled. So whether it was connected or not, to check that one, just hold on the conveyor and drag outside, so that there will be two connectors here, which means it is connected. Again, drop back to its original position. Clear? Now the same thing we will be doing with this one. Now I want to connect M2 and M3, for which what is the procedure I need to follow? Click on the conveyor in the toolbox. After that, what I need to do?
It will drag from M2 to M3.
So before doing that, so if at all you want to cancel this one, so press escape, automatically it will be cancelled. You need to delete this connecting, delete this relationship. So I am click on this one and deleting, deleted. Same this one. Now conveyor. First, what is the first operation I need to do here? Where I need to click on M3 or M2?
So M2.
M2, sir.
M2, and after that,
M3.
M3.
done. Similarly, conveyor. If I click in reverse, see, instead I click this one and click this one. What happened?
There will be a bottleneck at M3.
Bottleneck? No. If I run the simulation, see what will happen. I'll reduce the speed. Okay. Before that, let me change the timings so that it is visible clearly. 10 seconds. Okay. 10 seconds. Apply. Okay. 10 seconds. Okay. And 10, 10 seconds. Fine. Now I'm resetting the simulation. See, for your understanding, I'm creating like this. So the material movement will be clearly visible. What happened?
Sir, blockage है
There
M3.
is
Okay, here at M3 it was blocked, but I have used a conveyor to transfer the material from M3 to M4. By what? Why it is not happening?
Conveyor is moving in reverse
so
mode.
because it's connected from M4 to M3 instead of M3 to M4.
That is why what exactly this defines is once the M4 is done, then the part will be automatically entered from M4 to M3. That is why, see, this is a reverse conveyor. If I add a thing here, see, I am resetting the simulation. I am adding this to this. Now see what will happen. Else, I will show you one more thing. I am deleting this connector and I am adding a conveyor between these two. Now have a look. Clear? So which means direction of conveyor will also plays a key role in placing the conveyor. So that is why if the material handling is in forward direction, then we need to use the conveyor in this manner only, which means like this. If at all I want to add a conveyor between these two stations, now I need to clearly, I need to have an idea. So where exactly it need to start, how the material handling will go into place. Here from M3 to M4, the material handling need to be done. So first I need to click M3. After that, I need to click on M4. Now this was placed. Now see, I'm placing them in directions. Now if I run this one, so this will be an output. So for output, if at all I want, I can directly add a conveyor to drain. Same with this also. Delete, delete, and I am adding a conveyor. Fine. I am resetting the simulation. Clear? This is how we are going to use a conveyor in the model. This we will call as a straight conveyor. Clear so far?
Yes.
Yes, sir.
Now I'm resetting it. I don't want this conveyor. Now I want to use the connector, a conveyor between these two stations. For that, there will be having a angular conveyors also. Two type of angular conveyors. One is a straight angular conveyor directly like this. This is called as an angular conveyor with 90 degrees of angle. And second one is curvature. For curvature, So you need to click on the conveyor. So what is the first point here?
M3.
So we need to click on M3. After that, so if you drag like this, then you will be having a straight line only. You won't be having any curve. But if you want a curve, then you need to press control. You need to hold control. Then what happened? So a curvature will be present. In which direction you want? You want in upper direction or lower direction? So you need to
Lower direction.
yes.
Lower.
So now select it. Done. Now only this part if you want, then it will be showing. So only up to this curvature you want, then press escape. If you press escape, it will be like this. Or else if you want to continue that one, then same thing. Conveyor, hold on the first object, then so hold on control, then you will be having curvature in downward direction you want. So click on downward direction, and if you hold the control again it will be giving me like this. If you release the conveyor, sorry, if you release the control button, then again it will be showing me the straight lines. So once my conveyor was done, then I need to press escape. Now if at all I want to drag and drop here, or else I want to use the conveyor here itself, then I need to arrange this one. How I need to arrange? So I am deleting this one. Okay, conveyor.
सर
Yes.
आप सर ये कन्वेयर वगैरह डिलीट कैसे करते हो एक बार ऐड करने के बाद?
Okay, fine. Click on it one and press delete button. So whatever the icon you want to delete from your model, then press on that one and click directly delete. So it will be asking you message delete. That's it. If at all you want to remove a mission, then click on it and delete. So it will be deleted. Okay, now conveyor, click on this one. Now I want angular one, then a straight one, then again angular one, then a straight one. Done. Now I want to check whether they are connected or not. So I need to click this one. Yes, they are connected. Still, if at all you want to check, then hold all these things and drag here. There is a connector between these two, which means it was connected. Fine. If I run the simulation, then see what will happen. Okay. See, this is what exactly the model is. Clear with the conveyors?
Yes, sir.
Whatever. See, again, a mission is there and another mission is there and one more mission is there. I want to connect these three missions by using a conveyor. Then see they are not in a linear direction to give me that. So I can place a conveyor like this. See, not like this. But it is not at all correct. A conveyor won't be like this. For that, I need to delete and I need to place and hold a control and hold a control and I need to drop down. Done. Then I need to place here. Yes, it was connected. Clear? This is what exactly conveyor is. This is how we are going to place a conveyor in the model. Okay. Like the mission, if you want, you can name the conveyor also. See, there is a conveyor, conveyor 1, conveyor 2, conveyor 3, conveyor 4. I don't want these names. Instead of it, I can directly right click on it and rename. There I can directly use C1 as my conveyor 1. And this will be C2. And this will be C3. This will be C4. This is C0. C0, C1, C2, C3, C4. 4 conveyors. Fine. Basic material handling will be done in the industry like this only. So however the material handling will be there. So wherever the material handling there automatically conveyor will be used to increase the material handling. Now because of the conveyor, will my blocking phase reduced or increased? See in the previous model, what we have defined here, what is the time here? This is 2 minutes. Apply, okay. Now this is 4 minutes, I hope. 4, okay. And this one is 1, okay. And this one is 2. Now what will happen to the production? I want to maximize the production. I want to increase the speed and check. Now will there be any blockage? Have you identified any blockage in this model?
No, sir.
No, sir.
But previously there was a blockage at M1. Why? Why? Why there is no
Because
blockage?
earlier the material reached M2 but was not in process, but now it is between M1 and M2 and it has not reached M2.
Okay. Here in between M1 and M2 there is a conveyor. Conveyor is capable of holding material, maybe based upon the capacity. If the conveyor length is defined here and I want to give the capacity, like the conveyor can hold only 10 parts, like I can define the conveyor capacity also. At the same time, if at all I want to minimize more than, I mean more, then I can increase the length of the conveyor like this. So that what will be happen? Now this conveyor will capable of holding at least 10 to 20 parts, so that what will be happen, the blockage in the process will be reduced. So this convey they part, this is called as a work in progress parts, this can be reduced. I will try to do some alternative methods to reduce this one, so the process will going to happen. This is how we are going to run in an industry. Okay, now the next method is, by using conveyor we have defined, we have reduced this bottleneck in the process. Now next thing is weightage. See here, there is this much of waiting phase, there is this much of waiting phase. How to increase this one? Now we have completely eliminated the bottleneck, I mean
By,
blockage in M1.
so by adding more missions at M2 with means with parallel M2.
Okay, by adding more missions at M2. Fine, okay, according to you, I am adding one more mission here. And the name of the mission is M2 1 alternative mission. Okay, I am going to connect, just a second, let me reset the simulation. And here from this mission, one more thing, from a mission you can add n number of conveyors if this is a mission. So there is no any rule like one mission one conveyor, like there is no any rule for this. If at all you want, you can add a multiple conveyors. Like I can add n number of conveyors from that mission. What will happen with this mission is, this mission will give some condition, which means first part need to be entered on which conveyor, second part will be entered on which conveyor. That process can automatically happen. See here, now these many conveyors is there. Now what happened, this station will give first part to the first conveyor. Out of this, which is the first conveyor? This one is the first conveyor, so the first part will be entered into this one. What is the second one? Maybe this is the second one, the second part will be entered here, third part will be entered here, fourth part will be entered here, fifth part will be entered here. Again it will follow the same cycle. Based upon that, the material will be distributed equally to all the conveyors from this station. Okay, now I am deleting all these things. Here there are two missions, now I need to connect it from this mission. Okay, at the same time I'm going to connect this mission. Okay, done. Now I am deleting one more thing here. This chart is defined for how many missions? If I open this one, how many missions are shown here? 1 2 3 4. Now we can't modify it. Once a chart is defined, it will be like that only. If you want to modify it, it is not possible. For that, you need to delete this chart, and again you need to import it. Okay, I will explain you the chart session when the time comes. 1 2 3 4 and 5, 5 different emissions I am drag and drop on this chart. Okay, now this is what exactly the chart bar will be. Now see m1 m2 m3 m4 m5. Now I am resetting the simulation, running the simulation. Now what happened?
The waiting part has been decreased.
M2 dash. What happened to this M2 dash? It was connected and everything is perfectly. But why still there is M2 dash is having very less? Hardly it is using 5% of process. Why it was happened? Now how to increase M2 dash process?
Maybe
Sir,
it's
by
in the desktop compare.
Sorry.
Sir, we can increase the M2 dash working by means giving equal operating time to both and equal length of conveyor belts.
Okay, here sorry I forgot 4. Apply 4. Okay. I forgot this. Now it was working perfectly. Why? Because initially I haven't assigned that actual time. This is 4 minutes of time and this is 4 minutes of time. M2 dash is an alternative mission or a replica of the M2. So now we have defined two different processes and we are connecting with M1. So what happened here? The parts from M2 will be equally distributed. Whenever a part is coming, it will be one part will be reaching to M2, another part will be reaching to M2 dash. So that what will be happen? These two processes will be diluted. Now from this again the part will be collected at M3. Now again, see there is M3 waiting. How can we supposed to increase that M3? Is there a possibility to increase M3?
One more machine if we add.
Mm, and one more thing here, in industry perspective view, we can't increase the number of missions like that, right? See, the cost of one mission is maybe some 1 crore. How can we supposed to increase to 3 or 4 like this? So the mission maximum is two. Up to two we can increase and we can give the program, but beyond two we can't go. Why?
Sir, can you decrease the speed of M3, sir?
Speed of M3, which
I
means
mean processing time and all.
how can we supposed to decrease that? See, maybe M3 is a drilling operation. So for drilling operation, it will take 1 minute. How can we supposed to reduce that? We can't reduce that, right? So I can't
I
adjust it
mean
to,
increase like it taking 1 minute, so proportionally we'll increase it to 2 or 3 minutes to make it slower. So as to catch up with M2 and M2 dash.
okay, fine. As you said, I will explain you one more thing here. Same thing. The operation will take 1 minute. Okay, whenever a part is entering into a mission, it will take 1 minute to complete the operation. Now, 1 minute is its time. How can we supposed to increase at the same time? How can we supposed to decrease it? We are not doing it manually. So we are using a CNC machine or by using conventional machine and we are doing the operation. The operation is going to complete in hardly 1 minute, max to max. Either it complete in 45 seconds to 1 minute, in between it will going to complete. How can we increase it from 1 minute to 2 minutes? So in plant simulation, we can't alter the processing time. Why? Because processing time is fixed one. For every mission, for every process, there will be having a certain time. So we can't increase or decrease the processing time of a mission. So we can't change that. At the same time, there is
So,
one. Yes,
so to decrease the waiting part of M3, we either we can increase the material handling time. Means
material,
between M2 and M3, we can increase the material handling time.
which means It was initially 45. Let's see what will happen. Now, in industry perspective, waiting is okay. Okay, if there is a blockage, then definitely we need to reduce the blockage, we need to eliminate the blockage. But if the machine is having waiting phase, it is okay, which is a non-negative error. So which means we can try to eliminate it, but mostly it won't be eliminated. Why? Because it's depending upon the processing time of the mission. So waiting is okay. This much of waiting, we can't do anything with this mission. Only thing is, I can add. Now what exactly it means? See, now I am defining some mm, what I have defined here. What exactly it means?
It means we are means हम लोग कुछ प्रोडक्ट्स को पहले ही निकाल रहे ले रहे हैं उसमें से.
Now, see, previously this is what
बेसिकली
exactly the
हम
model
M3
is.
को एंगेज रख रहे हैं और प्रोडक्ट और रॉ मटेरियल देके.
See, in the presentation, I hope so. In the starting presentation, I explained you resource utilization, mission utilization. If my M3 is there, each and every mission is utilizing 100% of power, out of which M3 is not running up to its mark. Now I want to use this mission also, so that what I am doing here, what exactly the operation it is performing, I am giving additional responsibility for that mission, which means additional source, additional input. When I run this one, what happened? Now this machine is also using 100% of efficiency, which is additional input, which means some from other source, or whenever the machine is ideal. So at that time, I will be using some other process, some other raw material to do the same operation from that machine. So that what will be happen? This machine is also utilized up to its mark. Clear?
Yes, sir.
सर
Yes.
सर एक और दोबारा एक्सप्लेन करना है M3 का कि ये कैसे इंक्रीज हुआ, ये जो इसकी एफिशिएंसी है.
Yes. 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 See, this is what exactly M3 is, initial model is. Now M3 is utilized up to 45%. Okay, we cannot increase beyond this. 45 is the maximum. Why? Because we can't we can't decrease the processing time here, we can't increase the processing time. At the same time, we can't increase this number of missions anymore. So that what will be happen, M3 is constrained with 45 percentage only. We will be achieving max to max 45% in this process at M3. Now, according to an industrial perspective, according to industrial person's perspective, I want to utilize this mission maybe max up to 75% or 80%, whereas 50%, less than 50% is not at all acceptable. So I want to increase this M3 capacity, M3 usage. So that what I need to do is, what I will do is, I will be adding another source, which means I am adding another operation, another set of raw material. I am giving some raw material to this one to do the same operation. So I am assigning some sort of work to the M3. Why? Because M3 is having some ideal time. M3 is utilizing only 45% and rest 55% it is sitting ideally. So I want to utilize that 55% also. Let us say an example. This machine is working for 1 minute and it is waiting for next 3 minutes. Again it will work for 1 minute and again it will work for 3 minutes. So I want to utilize that 3 minutes of time also. So instead of sitting ideally, I am assigning some work to that mission in the meantime, in the rest time. That is what exactly this additional source is, extra source. I am adding some material to this one. So what happened? This mission now, see, now this mission is fully occupied. If I make it slow, then you will be clearly visible. See here.
यस सर.
Now see, instead of sitting ideally, a part is entering into this one. This is performing. The part from M2 is haven't received. See, it is still in the process. Why? Because it's having 4 minutes of processing time. Only after completing the 4 minutes of processing time, this mission will give the part to the M3. In the meantime, what M3 is doing? M3 is doing this alternative process, alternative work, so that this mission is won't sitting idly. So what will be happening? See, this is a process, it is running continuously, and now the part is coming here and it is waiting. Once this processing was done, then automatically this part will be entered here. See, this part and this part will going to enter. This will do the process simultaneously. It will going to happen, which means what will be happen? This M3 is completely utilized as of now. I'm giving some additional source so that what will be happen? This M3 is utilized up to its 100% mark, and this process also running perfectly. See, there won't be any blockage to these missions. Why? Because whenever the part is coming, it will be waiting for hardly 30 seconds or 1 minute, and the processing is happening. So because of this process is not at all halted or not at all affected because of this additional source. At the same time, this machine is not sitting ideally for the rest of the time. It is also utilized up to 100%. Now what happens if I increase the speed? I'll get what I want. Clear?
Yes, sir.
This is how we are going to run or optimize the simulation. This optimization part, no, don't worry. First, I will explain you all the tools. Then I will explain you what are the different methods for doing this optimization part. Right now, I want to show you. That is why I have added this optimization method. But as of now, it is not necessary. So I'm saving this model. Yes, it was saved. Fine. Next one. So I am done with conveyors. Clear so far regarding conveyors? Or any
Yes,
doubt?
sir.
See, a
Yes,
mission
sir.
and another mission. If there will be having two or three missions, I want to connect. Sorry, I want to connect this station with these three missions. Then directly by using this conveyor, there is a conveyor icon. Directly I can click like this, or directly I can click like this, or first mission and end mission like this. This is one method. Second method is systematic method. Systematic method is nothing but following the principles exactly: straight line, conveyor, angle, and a conveyor. Now I am going to place it according to it. Similarly, same from this mission I will be using this. Okay, this is how we are going to connect. Clear? What is the main purpose of using conveyor? Now you tell me, what is the need of using conveyor?
So to reduce blockage and for material handling.
If there is a process in an industry, it will be connect like this, which means a human is coming, or by using some material handling devices, the material is transferring between station 4 and station 5. Now what will be happen? There is a condition, there is a case for getting blockage. To eliminate that, only to eliminate that, industry will use conveyor. Conveyor can be used for two different things. One is for smoother material handling rate, so that the material will be traveling from one station to the station in a smoother way, and it will be clearly visible. And second thing is to reduce the blocking. That is why, that is one of the main thing we are using the conveyors in industry. With using the conveyors, what exactly happened? There will is the bottleneck between these two stations, the blocking phase, that will be definitely reduced. But what will happen if, see, the length of the conveyor is this much. Now sometimes what happened, there will be having some waiting also. That can be acceptable. That waiting can be reduced by considering, by reducing the length of this conveyor. See, if I reduce the length of the conveyor like this, now what will happen? Will the waiting time decreases?
No, sir. So because the performing time of machine is same.
performing at the same time. You are not following this material handling. It's a material movement. So a part entered this conveyor and it will take 1 minute to complete this complete path and reach the next station. So because of this 1 minute delay, what happened, there is a some waiting phase here. Now how can I supposed to reduce that? See, there is a 4 minutes of processing time here. This machine is having some 2 minutes of processing time. In between, this material handling will take 1 minute to complete its path. Now together, how much time this machine will to wait for a part?
5 minutes.
Now I am deleting this. See. Simple thing, a station and a conveyor. A part is entered into this one and it will take 1 minute to reach this destination from station to station 1. Station 1 is having 4 minutes and the material handling between these stations is 1 minute. So together how many minutes this station 1 will wait for a part?
So 5 minutes.
5 minutes. Now again after 5 minutes a part entered here. Once the part entered and it is executed, after 2 minutes it was executed. Now how many minutes again it will wait?
So 3 minutes.
Yes, 3 minutes. I want to reduce that. For reducing that, again I will be doing this. I am reducing the length of the conveyor. So that what will be happen? Now it will take 30 seconds to reach the station. Now will my waiting phase reduce or not?
Yes, sir.
That is the main reason we are using conveyors in industry. If there is a blockage, then we are going to reduce that by using conveyors. If there is a waiting also, we are reducing by using a conveyors, by length of the conveyors. That is the main advantage, or that is the main necessity of using conveyors in industry. Okay, for a smoother material handling rate and to reduce as well as increase the material handling between stations. Clear? There won't be having any restrictions for the conveyor. You can draw any type of conveyor. You can draw a straight line conveyor, you can go for an angular conveyor, you can go for a curvature. So based upon your layout you can do anything. Okay, now see, one thing I want to explain. Let me erase everything. Clear so far?
Yes, sir.
Yes, sir.
Okay, everyone. See, it is difficult to ask each and everyone by name. That is why I'm just asking you. If you are having doubt with this one, kindly ask me. If it is clear, or else just is clear, then we will be continuing to next session. Clear so far?
Yes, sir.
Yes, sir.
Yes, sir, clear.
Fine. Now I will be showing you one important thing here. See, there is a mission and there is one more mission. Control C, Control V. Okay, here I am using it was connected. Now here see, I am using angular converter. There is a separate option, angular converter. Here I am using, and I am using fine. There is no any connection between these two. If you want to connect a mission with this one, then don't worry, click on the conveyor and click on the mission, it will be connected. Now what is the difference between these two? Can you explain me? Anyone? There is a curvature conveyor here and there is an angular converter is there. What is the difference between these two? Okay, don't worry, I'll explain you. Now I'm running the simulation. So this is, I'm resetting the simulation, I'm reducing the speed and see what will happen. Oh, okay. source 1 is connected with station and source 2 is connected with station 2, and station 1 is connected with drain and station 1 is connected with drain 1. Now I'm running the simulation. Now what exactly happening here? Can you identify anything?
So the curvature one is reaching more means faster than the second one, means 90-degree one.
Okay, fine. Other than that, other than the speed,
Uh, the curvature one is moving smoothly.
no.
So in second part is stopping at the start beginning of the angular converter.
Okay.
शो होना चाहिए तो वो वहां पे रुकेगा कन्वेयर पे, फिर दूसरे
Sorry, your voice is not audible. Can you repeat it?
सर आई एम सेइंग दैट कि एल शेप वाले में जो
Mr. Ashmit, after this L shape, your voice was again delayed.
ओके
Fine. See, you have seen, you are observing the speed, you are observing the halt which is taking at this angular converter, but I hope you haven't observed the orientation. You see how the product is oriented with respect to conveyor, how the rectangular part is converting its shape, converting its orientation from these two conveyors. Just observe that. See, is it visible? Guys, am I audible?
Yes, sir.
Is my model visible or it was stuck?
सर इट वाज स्टक
Visible.
सर
Just a second, let me check what happened with this. How about now? Is it visible?
Yes, sir.
Now, see, have a clear look on this one. I'm resetting the simulation. I'm running it. Just observe the orientation of part on these two conveyors. Angular conveyor, arc conveyor. What is happening with the orientation of part? In the first conveyor, I will call this as a first. In the first method, so what is the orientation? How the part is entering, how it was traveling to the station. And what will happen with this one? what is happening in process 1? Hello.
So in case one, the product is entering in station two as it is exiting in station one. But in case two, the product is entering in the station after rotating by 90 degree.
Okay, just a second. Is the simulation working or it was stuck? It was stuck.
So in between it is stuck, but means
Okay, fine.
अभी
there
तो
is like
स्क्रीन फ्रीज है.
Okay,
yes a network lag there.
just be online. I hope there is internet connectivity problem here. Guys, am I audible?
Yes, sir, you are
Yes, sir.
audible, but
Okay, fine.
yes, true.
The screen, I'll leave the screen. I don't know what I need to do with this one. Fine. See, I will explain you these two cases. In case one, what is happening? So the part is entering in the conveyor and it will maintain the conveyor orientation. So whatever the length of the conveyor, what is the angle of the conveyor, that will be followed by the angular conveyor. I mean this curvature, case 1. Whereas in case 2, we are using angular converter, which is not a conveyor here. This is an angular converter. What happened? Presentation stop. In case 2, what exactly happening is we are using an angular converter. In the angular converter, what exactly happening, it is maintaining the part orientation. So how exactly the part is entering the conveyor, that will be maintained here. See, a part is entered in a rectangular manner, so and it will maintain that rectangular manner and it will be entering into the second machine. Whereas in case 1, what is happening, a part is entered in a rectangular phase and based upon the conveyor. So if it was rotated in an angular direction, so based upon that the part is also rotated. Whereas in case 2, the orientation of the part is maintained. That is the difference between this conveyor as well as converter. So if you don't want to, if you don't want to maintain the shape, don't maintain the orientation, then definitely you can use this conveyor at this corners like this. If you want to maintain the orientation, then definitely you need to use this angular converter. Okay, that angular converter is this one. Just beside this conveyor, there is one thing called as an angular converter. Okay.
Yes, sir.
Fine. There is internet connectivity. Fine then. Okay, I will stop the today's session as of now. Try to practice these models. Create different models by using this type of conveyors, different form of conveyors like a straight conveyors, some curvature conveyors, different one mission to four or five different conveyors. Like try to create different models and be expert as be practice this conveyor section completely. And if you have time, so if you are thorough with this angular converter also, try to use this angular converter also. Otherwise I will tell you that in tomorrow's session. Okay, there is a problem having internet connectivity here. Even though if I continue again, it will be a problem for you to understand as well as to see this one. That is why I'm just stopping today's session. Today's session practice these things like missions as well as conveyors. Try creating some 5 missions, 10 missions, 20 missions in a model, different layouts like a straight layout, placing all the missions in a line, placing different rows like 5 missions, 5 to 4, 4, 3, 2, 1, like prepare the model in some ascending order, descending order. Try to do all those things. Okay, and by using conveyors, try to use the material handling, how the material handling is happening in actual. So how a straight conveyor will be happened, what happened if you reduce the length of the conveyor, what happened if you increase the length of the conveyor. Try to do that also. Okay, clear.
Yes, sir.
Okay, there won't be any assignments as of now. Why? Because you need to practice it. Okay, as much as you can practice all the tools, these missions input and output, try to rename it. Try to use some 5 missions or 10 missions, more than missions. If you use some 20 missions or 25 missions, what will be happen? You know the complexity of the problem, you know the complexity of connecting between stations, you know how much difficult the material handling if there will be having more number of missions. See, if there will be having two missions and between two stations you will be using a conveyor, it is easier. So if there will be having 20 missions and between those 20, I mean among the 20 missions, if you use some material handling device like this conveyors, then it will be having a real time problems like how the conveyors will be connected. So which mission to which mission it will be connected. So if at all I am reducing the speed, what will be happen? If I increase the length of the conveyor, what will be happen? Try to do all those things. Okay, and if you found any difficulties or if you having any things, kindly note it down, and on tomorrow's session kindly ask me, I will explain you all those things. Okay,
Okay, sir.
clear. That's it from my side, guys. Yes, what happened? Ryzen and Mr. Satak.
Sir, it was a misclick.
Okay, fine, no problem. So that is what exactly you want to do for today. So practice this model. Open a new model, in that create a new frame with a frame having n number of missions, maybe 5 missions one model, 10 missions second model, 25 missions third model. By creating 25 missions, and finally add all the material handling by using conveyors, different form of conveyors, straight conveyors, some R curvature conveyors, angular conveyors. Try to use all those things in your model and practice it. That's it. Okay, that's it from my side, guys, today. We'll meet you tomorrow.
Uh,
Thank you, sir.
Thank you. బెబో ఇక్కడ ఇంటర్నెట్ వస్తున్నది బెబో సెషన్ కట్ చేస్తాం చెప్పు
మనం